So, welcome students. Welcome to Cybervidyapeeth Foundation. And our data science session is running. And today we are going to learn about some NumPy array. That means how we can convert images to NumPy array, and how a NumPy array convert with an image. So I will wait more 5 minutes. That's why more student could join. So, okay. All of you students, please join first. Because today we are going to continue our class at least 3 hours. Yes. Okay. Yes, good evening to all of you. Let's start how to converting image to ND array, or you can say NumPy array. So that's where you can train your images for your model. Okay. So important module that's name is pillow. I'm writing here. Yes. Pillow. Okay. So pillow is a Python library which is nothing but the aggregation of pill module. Okay. So you can install it with this simple command, that means pip install pillow. Now why this for pillow? This is nothing but it preferred something like this, that image manipulation tool. Okay, so also I'm writing here that it is nothing but, so it yes. Image manipulation tool. Okay, so now I want to check that my module PIL is available in my Python library or not. So how can you check it? This is our module, that image import pill. This is our module, and if we want to check that it's already available or not in my Python library, yes. So pillow version, if we write something like this, that pill dot underscore version, yes, after that underscore it will print, yes, that my pillow version is 9.0.1. So it's available. Okay, so let's start with the image, simple image that I already save in this folder. That is, yes, simply you can see this the light of some simple image. So let's start with this image. So at first, this pill, inside this pill module, we have a function that is open. Okay, so what is the working purpose of this open function? So it will open an image where a existing image just like this. That means here inside this folder there is the image. So I want to open it in this Jupyter notebook shell. Okay, so let's check. So I initialize a variable that is image, and inside this image I want to store the image. So now you have to call image.open, okay, which will open up an image, and digital file format can be retrieved as well as pixel format. Okay, so inside this open function, just give the path of the image where the image already set. Okay, so I'm giving the path here. Look carefully that my image inside my users. Yes, my username. Yes, inside desktop. And also you can simply, I am showing you that simply you just go inside the folder. Yes, inside the folder. And after that, where is our image for class? Yes, here is our image. Just a second, where is? Okay, wait. So yes, here is our image. So simply how you will get the path, I'm showing you that just open it into a new terminal that is also available in Windows. Okay. And if you write a comment that is pwd, you will get the path. Okay. So pwd for Linux, all of you know that. Okay. So the directory. Now I'm giving here the path and the image name, that is yes, sample.png. So it is a PNG format image, or you can load some JPEG format image, anything. Now we want to see that what is the current format of this image, format, current size, and what is its mode. Okay, so if we call something like this, that image dot format. Okay, image dot format, and if I print it, yes, if I print it image dot format, so wait, yes, so we have to import image from pill. So what is its means? Just look at here, from this pill module. Okay, it's a module, and inside this module there is a class that name is image. Okay, so I want to import this class, that image class. Okay, so just a second, let me load my drawing notebook that I can show you. Yes, 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 here we go. So it's nothing. So suppose this is our pill model. Okay, and inside this module there are a lot of classes. Okay, and every suppose class 1, class 2, class 3, and every class has its own working purpose. Okay, so inside this pill method, one class is that image. Just a second. Yes, and inside this start with capital I, and inside this image class there is a function that is open. Okay, So that's why here is the error. So we need to that you can see here that what is the error, that image is not different. So I have to define it at first. Yes, like this. So now if we open, so you can see that this image sample.png. Yes, good evening. Yes, good evening all of you. So this sample.png is a format of png. Okay, so if now uh, we want to see what is the size of this image. Okay, it must have some size, this into this. Okay, so if we something call like this, that image dot size, so yes, we can see the size of this image is 400 into 200. Okay, this is the length and width. After that, what is its mode? All of we know that RGB mode. Okay, what is this RGB mode? Red, green, blue, combination. Okay, so again, if we want to print, yes, what is its mode? That means image dot mode. Yes, so it will print its mode RGB. Now we will see that converting this image into numpy array. Okay, so many method is already we have some methods. That means suppose as array, then numpy array. Okay, so we will start with as array function. So as array function or method is used to convert a image into numpy's array. And this function convert the input to an array. So what is our input? Our input is this image. Okay. So now again we will load this image, and just from here we can convert it, because already we uh, store it inside this variable. So we can use this variable to convert it into a numpy array. Okay, so now again I am creating another variable. That means suppose numpy array image. Okay, like this, and we simply call the function as array. I am making a comment here, just a second, that you can understand where we are. So first method is using as array. Yes, as array function to convert an image into numpy array. Okay, now so inside this as array function, just pass this variable. Okay, so I'm passing the variable, yes, image. And after that, okay, after that we want to print now what is its type? Okay, so it is already done. Okay, so now if we print that, yes, type, please give me the type of this numpy array image, whatever we created. Now if we run this, okay, there is a mistake. So yes, because this function is not defined. Again, some error with this name as array is not defined. So as array, actually as array come from numpy. So we have to again declare that from numpy, yes, from numpy, please import this function, that is as array. Yes, we can see what is the function is as matrix, um, as f array. Okay, so we need as array. Okay, now yes, now you can see that this image is already converted into numpy NDI. Whatever we learned in the previous class uh, with numpy's module. Okay, now we want to uh, show, we want to see its shape. What is its shape? Okay, so simply if you print that, yes, numpy image dot shape, now you can see 200 into 403. That is its shape. Okay, so yes, you are unable to do it, but why? What is the error? You have to install this pillow library inside your Python library. Okay, so just open the Anaconda Navigator, whatever you are using, Windows or Linux. After that, if you using Linux, so simply type, after installing Anaconda Navigator, simply open your terminal. After open your terminal like this, open your terminal and just write a command, that is Jupyter Notebook. If you write this comment, okay, if you write this comment, this kind of window will open inside your browser. After there, inside the first cell, just write this comment, that pip install pillow. Okay, and if the numpy is not also available, just write pip install numpy, and like this, pip install pandas. Okay, so up to next, we are using numpy array. Okay, so method 2, inside method 2, so we are using numpy array to convert our image into NumPy array. So yesterday we see that how a simple data frame could change into a NumPy array. Just the simple method that is numpy.array. Okay, so as we already declared, no, we not declare here, so we have to declare that import numpy as np. Okay, it's clear. After that we have to again already we load the image, so I am showing you again that how can you load an image. I think some student joined late. Okay, yes, so see here inside this module, this is a class that is image, and inside this class we have an open function. Okay, so it will open your image. So my image is saved inside my desktop. Okay, and inside desktop there is another folder, and inside it this sample.png. This is a simple image, and after we open this image inside this variable, that means we stored the image inside this image variable. You can write here anything, okay, because as your choice. So now we want to convert it with numpy array method. So simply just take another variable, that is, yes, it will be a numpy image. So we just call np, that means numpy dot array. So this is our method, and inside is just pass the variable. Okay, just pass the variable. Okay, you are not able to read that file. Some UTF-8 error. Okay, Pranshu, what is your operating system? What is the name of your operating system? Yes, Windows 11. So if it is a UTF-8 error, that means UTF-8 is exactly, it's an unsigned long. That means a long. Okay, we will discuss about your error after this class. Just keep patient and don't worry. So where we are? So I'm passing this variable inside this function, and after passing, now we want to again see what is its type. Okay, so it already converted or not. Okay, so just give where the new variable name, that is nps image, and we can see yes, it's already converted. But before you convert it, if you print the type of this image, you will see that it is a png format. Okay, but now after convert, you can see here this is a numpy nd array. That means it's already a array, it's already converted into an array format. I will show you that how long the array exactly is. So in order to get the value of each pixel. Okay, each pixel, that means suppose here we, so inside a image, so already we know that inside, that means 720. What is this means? That means this is the pixel, that means small uh, shape. Okay, so this small shape is converted with a array. So we will see that if we want to view the value, so just nothing you have to do, just print this image, converted image. So if you print this np slash underscore image, yes, like this, so yes, you can see here that all of our image is already converted into a array. Okay, so every for image, that means for deep learning, you have to do some project where suppose you have want to do some project with image. That means if it is a simple, I'm showing you, so that suppose we have a image that this is a dog, okay, and this is a cat. So you have thousands of dog images and thousands of cat images. Now you are a human, so you can easily identify that which is a dog, which is a cat. But how can computer will give you an output? Okay, computer will give you an output that this is a dog or cat. So for this purpose, you have to work with these images. Okay, so for train these 2000 images, you have to convert all the image. I'm writing here, you have to convert all the image into a array. Okay, so again we come here. So already here as a single image, we already see that a simple image, how you can convert it into a array, and that is our value. Okay, so after that, now this is an array, it's okay, but getting back the image from converted numpy array, that means there is this array and you want to again change into you want to change into image format. Okay, so how can you do that? So let's know. So again, from we are importing from pill module, pill, that means pillow. Okay, the image class. Okay, after that we already also need the numpy arrays. From numpy, yes, import as array. Yes, after that Load the image. All of you know that how can we load the image easily. So again, image is equal to image dot load. Sorry, open function. So I'm showing you again and again. That means you can easily remember. Okay, because it's so important. Okay, so here is my path. So I'm simply copy this path. Yes, I'm copying the path. Yes, so already image is open. Now I will make it again with some array. Okay, so numpy array. So I'm converting this image into an array, and we are using as array. Yes. After that, pass the variable image. After that, we want to print its type, and simply pass this variable. Yes. Oops. Yes, numpy array. Now, also you want to print, suppose the shape. Yes. So this is our first task that I already make it into an array. Now I want to get back this array into an image. Okay. So after it is clear. Okay, sorry, this is not type. Okay, this is the shape. Yes. Okay. So it's already created this image into a NumPy array. Now we want to get back this array into an image. So simply we just create another variable. You can say here I want to image. That means image is equal. Now here is a interesting method that is from array. So what is the working purpose of this method? That it will say something like this. That means, hey, array, give me the image return. Okay. So like just yes, image dot from array, and this is my array. You can see what is its type. Its type already we print here. Its type is an array. Now we want to get back the image from this array. So this method simply just telling us that, hey, give me inside this parameter, inside my parameter, give me an array, and I will convert it into an image. Okay, something like this. So I am passing this array inside this from array parameter. Yes. Now, what is exactly happening here? So this array, so image is called that, give me an array and I will convert it into an image. Okay. So just a simple method, change an array into an image. So don't forget this function, that from array. and as array. Okay, these two method always remember. Okay, now if again now it's done. Now I want to check that it uh, already done the conversion or not. So again, simply just check the type. Check the type. Yes. Type of this image. And after that, yes. If you want to check the type, so you can see here it's convert into a image. Here is the class. Okay, that means it is a image. Okay, now also we want to see its mode, its size, its format. Okay, so just I'm copying from here. Okay, no, that here just print that image dot format. Okay, yes, and I want to print image dot size. Also I want to print image dot shape. Okay, yes, shape is not available. Okay, why? Okay, if you want to see the mode, yes, now you can see that this is a RGB mode. Okay, but our format is none because it couldn't identify the image after conversion, but the mode is RGB. That means yes, it converted into red, green, and blue combination. Okay, and size is you can say you can see 400 into 200. Whatever we get here, yes. At first, after opening the image, the size is 400 into 200, and again it already changed. Okay, so now our important one of the another module, that is TensorFlow, and inside this TensorFlow we have a method, or you can say function, that is load image. So here we already use this opened function, but now we will use load image function. What is it? Load image function. So I'm simply, so if your computer does not exist TensorFlow, just simply install it by this simple command pip install TensorFlow. Okay, and also we need another module, that is pip install Keras. So Keras API, it's nothing but it's provide the function for loading, converting, and saving image data. I'm again repeating, that means Keras function is for loading the image, converting the image, and also saving the image data. Okay. So after installing Keras, just we want to import our load image function. So the function I'm commenting here, one step before, yes, where we are that we're going to learn about load image function. Okay. So now from TensorFlow, yes, here is my TensorFlow. Inside this TensorFlow, we have Keras. Yes, Keras. Inside this Keras, we have a function, or you can see class, that is pre-processing. Yes, pre-processing and image. So from this, import our load image function. Okay. And we will also import some warning. That means we can avoid for some threads. Yes, yes, like this. So no module. Yes. Now, yes, it's okay. It's already loaded. Now, after that, simply again, I am strictly call this function that load image. That means, yes, inside this, just give the path. Just keep this path, and it will load our images, and it will store inside this variable. Okay. Again, we if we want to see its type, format, mode, just call that image.type, image.format, image.mode. Okay, like this. So let's check what is its format. Okay. So image.format, just one, that it loaded or not. Okay. Yes, it's a PNG format. Okay, it's okay. So that means we can say our image is already loaded. Now we will see that using this Keras API, convert images to NumPy array and reverting the image from NumPy array. Both, whatever we done with this as array as array method and NumPy array method, but here we use a module that is spill, and by the support of the spill module, we open the image and store it inside a variable. But now we are using keras. Okay, so I already told you that keras is the function for loading, converting, and saving image data. So you have two options. Either you use pillow or you can use TensorFlow class. Okay, so both will be same, you can say, not fully same, but the working here, whatever we are working, it's give us the same. Okay, so simply we already load the images and now we will convert it into NumPy array. So for this we have to import a lot of modules. At first, TensorFlow, so we can rename it because it is a long word. So every time you have to write this, the TensorFlow dot this method, TensorFlow dot this method. So that's why you can short it, that TensorFlow as TF. Now again, from this module, okay, from this module we will import at first load image. Already we done this, so don't we need it because already we done this and already we load the image. So now we have to import that very important function, that is image to array, array to image. It's very simple. Okay, so yes, image to array and array to image. So we will simply use two functions for converting an image to array and array to image. So I think this process is much better than this pillow. Okay, the both are actually both are simple. So again we have to import the warning. That's why yes. So now already we load the image into this variable. So now just we convert it, that means image to array, and it will convert the image to array. This is our variable, and now simply call this function. Yes, image to array, and inside it its parameter. Okay, inside its parameter just pass the variable. Okay, yes, like this. So it's done. It's simple. So now as we want to print its type, that what is its type? Yes, you can see numpy and array. So is it clear to all of you? Yes, pip install TensorFlow. Don't mistake in, I'm coming to the comment. Don't mistake in spelling. Yes. I'm not able to install TensorFlow. Why? Are you using Anaconda Navigator? And also Pradhan, module not found, error. Okay. So whatever module is not found, if you have a error, that module is not found, name this is not defined, just install it with pip. That means I am working with this Jupyter with a lot of time. That's why all the module is already installed in my system. Okay. So just pip install anything. What is a module is error, giving you the error, just pip install warnings, pip install TensorFlow, pip install keras. Okay, like this. Just install. It's already installed. So why you will getting an error? Okay. So I think after installation, you will there will no error, and if any error, just uh, have a look in your code that you done any mistake or not. Okay, your variable spelling is right or not after when you want to call it. Okay, so like this. And I think all of you, yes, all of you, I think you will join the internship session. So anyone who have errors some this type of problem will solve it personally. Okay, so don't tense about it. Just I am showing you the process how you will done this type of conversion. Okay, just remember it. Don't feel hesitate with this kind of error. If some error, uh, you can search also internet, so it will show whatever what kind of module uh, is already not in your system. Object is not callable. Yes, for this type of image conversation, at first at the beginning you will you have to you will face with some kind of this type of error, but don't worry, just uh, join our course. We will handle it with personally. Okay, don't worry. Run the command in case of Anaconda Navigator. So yes, Kishan Verma, if you already download the Anaconda Navigator from its website, after downloading it, just install the exe file if you using Windows, and after installation, go to your command prompt and just write Jupyter notebook. It will open. inside a browser with this type of, yes, like this. Yes, you it will open inside your screen, and after that just create a folder into your desktop, and inside this folder take a random image from anywhere and open it like this. Load image, or uh, you can open it by pillow module. Okay, yes, image.open. Because we will see where why this error. Okay, what is the problem? I think you can doing some path error, some kind of you just in your code you have some mistake. So that's why this kind of error. And if you cannot face where you if you couldn't face with the error, so you cannot learn. Okay, the array values as zeros. So it's depend on your exactly your image. Okay, so I'm coming just I just complete the session, today's session. So I after that I will yes, path error, no path error. Okay, but whatever I am showing you, there is all the things is I think clear. So just answer me that whatever I teach you, is it clear or not? We will handle in future whatever you have this kind of error, but is this clear or not? Because I am showing you also the output. Yes, clear. So uh, just we will, yes, move ahead. After that uh, we will handle it with personally who have this kind of error. Just join our session or some paid course. So already we done here that this image is already converted into an array. So if we just print this image to array, again I'm showing you that if we just like this, yes, this is our total array. Now we want to convert this array into again image. Okay, so just nothing have to do that you just to write this kind of write a variable to image is equal to, and call the function array to image. So I will prefer you that you always use these two method, that is too important, and also it was easy, that image to array, array to image. Okay, so now I'm passing this array inside this parameter. Yes, like this. After passing it, now we want to see the type of this new image. Okay, so simply print the type of these two images. Yes, like this. So you can see this is also an image. And this is done with our TensorFlow load image. I'm writing here that using TensorFlow and Keras. But now another library is OpenCV. I think all of you know about OpenCV. Yes. So I'm again commenting here. OpenCV, using OpenCV. Yes. Library. Yes. So simply just install it by this simple command, that is pip install, but not OpenCV. It has another name, that is, I'm writing here, OpenCV, after that dash, then contrib dash Python. Okay. So this type of library, that means NumPy, Pandas, TensorFlow, then Pillow. So just you have to install this type of library inside your Python. So anyhow, you have to install it. And if you have some problem, we'll discuss it inside our paid course. Okay. So as CV2, these CV2 packages, so let's start with our, yes, this is our module, that is CV2. And after that, simply we have a function. Okay, we have a function that belongs to CV2, and the function name is ImageRead. The shortcut is imread. Okay, so inside this ImageRead, just pass the path. Okay, so I'm again copying this path. I am showing you the multiple options. That's why you haven't any problem. In future. So now I want to make this image into a numpy, but it is too clear that this will, we all of you know that Bezier, RGB, this is the yes, this is the format. No, not format. So this is the, yes, format of the image, not format. Just a second. Yes, mode. So what is the mode? that means different kinds of mode, that is BGR, RGB, that means red, green, blues combination image. Okay, so simply just image into, and we call this function module CB2. Inside this CB2 we have a function that is CBT color. Okay, so the function name is CBT color. Yes. So if I call this function and inside its parameter, just pass the image, and after that inside this parameter we also can call the CB2 dot color, that is capital. Yes, and inside this color we want that BGR to RGB. Okay, and it's done. So it will change the color of the image. Okay, so this CB2 has another function that is image write. So we read it. Now we want to write it again. Whatever we make changes between read and write. So we read this sample.png. Just a second. Yes. So this is our sample.png, but we want to make it with RGB. Okay. So just call the CB2 module and image write again. So write means we have to give a path and we have to give a new name, whatever we want to save in new format, new PNG file. So I am giving here the same path, and inside this path I am writing the output.png, and which image this after converted this image. Okay, so I'm passing the variable. So it will make changes that the color, here you can see the color we will change with BGR to RGB. So what is the current mode of this sample.png? Please, I want to answer. What is the current mode of the sample PNG? We see in before. What is the current mode? Anyone? Yes, RGB. Now you will show some changes after we save this PNG. So if we execute, it will save inside my desktop. Okay, so just yes, I think some mistake, just a second. Yes, there is a camel mount, yes, formation. Now I think it's okay. Yes, we have a output with true. Now let's check inside our here, and we can see here is the output.png. And yes, before the sample is like this, after we change the color, the sample is in BZR mode. Okay, so that is some example with our image, with some example with images conversion. And also you can create an image with an array, something like this I'm showing you. So after that we'll go for our today's simple mathematics, statistics. Okay, after that deviation, after that hypothesis and p-values. So don't go anywhere, just the last cell that we randomly here we randomly create an array. Okay, randomly we just create an array, and after that we will convert it into image. Okay, so it's very interesting. Okay, nothing we have, just to randomly create an array. Okay, and after that we will convert this array into an image. Yes, so we have to call from pil. Yes, import image as I am. Yes, after that I am creating a function, and inside this function don't feel hesitate to see this type of function. I will discuss, just see. So at first, yes, array. So today yesterday we see that arrange function. All of you can remember arrange? Yes or not? Arrange function. That means some random value will take from 0 to, suppose like this, 737280. Okay, and the difference is 1. After that the type is unsigned long. Okay, oops, yes. Inside this I'm printing the type of this array, whatever we created. Yes, type of this array. Just I will discuss, just follow me. After that we will reshape this array. I think all of you can remember yesterday whatever we discussed reshape. Okay, so now you can understand that where is the use of those functions. So I'm reshaping it into 1024 into 720. Okay, this is our matrix size. After that, we just want to check the second array shape, this array. So that means already this array is converted after reshape and stored it this array variable. Okay, and after that we just print array dot shape because they want to see the shape, that its shape is 1024 into 720 is or not. Okay, and also we print the array. After that, I'm creating a variable that is data and im. Im means this im, that means image. So I give it a shortcut name that is im. So im means this function. I am calling this function. So im dot from array, whatever we see previously from array. Inside this, I am passing the variable. Now it's already this array changed into image. So I'm writing here the image. Yes, you could better understand, and I'm saving this image into save function with a random name. What is name? Suppose created image by array. Okay, and what is its format? .png. Okay, I will share it. Nirmala, don't worry. Just ping knock a message inside our cyber group. One of our bot will share it for all of you. Okay, just knock anyone and remember us. And now, so it's okay, already it's done. This is our main function. Okay, so this is a function. I think all of you know about function. And how can we call a function in Python? Okay, I'm showing. So just underscore name underscore is equal underscore main underscore. So if this is yes, call the main function. So it's already done. Now if we run this, oops, this type of error. Okay, name reshape is not defined. Okay, Reshape is not defined. Why? Just a second. Yes, because I don't call the numpy, because reshape is under numpy. Okay. Yes. Oops. Data is not defined, of course, because I saved this image into this variable name. So I have to call this image. Yes, now it's done. But what is this? Oh my God. This kind of kernel problem. That means why this type of things I'm sharing you, because I am at the 99 cell. Okay, at the 99th cell, and previously whatever we discuss from 1 to 5, something like this, it will like this recall something. So I am simply copy it. Okay, so already our function is called, don't follow this. And here yesterday someone is questioned that what is this b. I think this b is represent for byte. Okay, because in yesterday we creating some object. Yes, here, because this is the name and its type is objects, and object is created by some with some bytes, and that's why inside this tuple is defined as that this is represented by. Okay, something like this, as I know. So let's see our image is create or not. So where is my, what is my path? Yes, path is the same directory. Yes, here we can see created image by array of png. You can see this type of image. Can you see it? Yes. So by a random value, we already create an image. Okay. Now let's go for our mathematical session, and after that, after this solving this mathematics statistics, we will go for matplot library. Okay, matplot library, that means we're going to learn how to create histogram, scatter, pie chart, then many kind of things. Now just simply follow me. Okay, so we will start. After that we will solve mathematics with Python Jupyter notebook. That how we can find the hypothesis and p-value with a claim. Okay, so at first I'm talking about mean. Okay, so statistics. Yes, one is mean, median, and mode. Okay, so Mean is nothing but we can say also say that means the average. Okay. So the average for some grouped frequencies data. Okay. So yes, short form. And median, that is represent, that means median is a value or a number that appears most frequently in the data set. No. Just a second. Median is the middleist value of a given group data. Okay. So you can write the middleist value. And mode is the maximum frequency, okay, of a given data set. That means it represents maximum number of time. Okay. Okay. Now, if we go for an example, suppose there is an example that number of defective bulbs in a class. Suppose yes. After that, this is our number of boxes. Okay. Yes. Yes, here. Now, from 0 to 2, 2 to 4, 4 to 6, 6 to 8, and 8 to 10. And our number of boxes is 3, 4, 5, 3, and 1. Yes. Now, we have to need the class mask. Okay. This is exactly whatever you done in the class 10 or 11 or 12, I don't know. I just, for our syllabus, we have to cover it. So if this is our value of x, and if this is our f, so simply fx will be, oops, sorry, there is some mistake inside the value. So number of boxes is, okay, wait. I'm clearing it. Our number of boxes is 1, 3, 5, 7, 9. And how no. number of boxes is 3, 4, 5, 3, 1. And our class mask, that is 1. So after 1, because the difference is 2 in every unit, so 5, then 7, then 9. And if this is the summation, and you can say addition and addition of number of boxes is total 16. And after that, if we multiply, so yes, 3, 1, 3, 5, yes, 12, 25, 21, then 9. So just simply multiply f into x. And what is our total of fx? That is 70. And what is the formula for mean? The formula for mean, and it represent with x bar. Okay. So the formula is summation fi xi, sorry, yes, you can write here, divided by n, now divided by summation of fi. So here is, you can say fi's value is 70 divided by 16, and the calculation value is 4. So that means approximately 4. We will deny this float number. Okay. So this is for mean, simple mathematics. And if we want to go for median, so we know that the middleist value, okay, so just a second, yes, so suppose a class interval and its frequency. So for median, so suppose here is a group of data that is class interval. Okay. One is frequency that represent fi. Okay. And these two were already provided. Okay. Class interval, that 0 to 10, suppose 10 to 20, 20 to 30, 30 to 40. Yes, 40 to 15. What is your frequencies? Is 5, 10, 12, 15, and 18. So don't go anywhere, because after this we will create some random values inside our Jupyter notebook, and with this data set we will create a hypothesis and p-value for uh, detect a claim that it will um, it will be reject or not. Okay, so just after finish it, just take some patience to complete it. So now for median we have to take the cumulative frequency. All of you know that. So what is cumulative frequency? That is, at first 5, after that 5 plus 10 is 15. So just increase with frequencies, then 27, then 42, then 60. Okay. And this is our summation Fi. That means the total addition is 60. Okay. Oops. And what is the formula? One more thing, that here n is equal 60. So n by 2 is equal 60 by 2, that is 30. Now, what is our formula? Our formula for medium, that is L plus oops n by 2. Wait. Yes. N by 2 minus CF divided by F into S. Now see here, what is L here? L is lower limit of the class. Okay. When inside where our, this is 30. So where our median is exactly exist, this class, suppose 27 is less than 30. So inside this class, our median is exist. So this class lower limit, that is our L. Okay. And what is CF? So CF represent the cumulative and frequency of the previous class. Okay. So of the previous class, that is, this is my CF. I'm writing here that what is CF. So CF exactly represent the cumulative frequency previous of the previous class. Okay. After that, F is the frequency of the median class. Okay, frequency of the median class. And what is our N? Sorry, N. What is our H? So H is the width of the class. All of you know that. Because already all of you, I think, done in class 10 or 12. That means difference between upper limit and lower limit, you can say in easily. Also writing M between upper limit and lower limit of the class. Now, what is the difference? Difference is 10 unit. That means 20 minus 10 is 10 unit. Okay. Now, just give here all the values. Oops. Yes. So all the values, that is 30 plus. So what is our F? F in this class, inside this class, our median is exist. So 15 is our F. So n by 2, that is 30. What is our CF? Yes, 27 divided by 15. And H is 10. Now, if we calculate this, it will getting out 2. That means 30 plus 2 is 32. So that is exactly our median. Yes, 30. Now, after that, we will see just a second. Yes, we'll see how can we get out mode. Okay. So yes, maximum number of time. That means value or a number that appears most frequently in a data set is a mode. So suppose we have some value that is, yes, mask is 0 to 10, 10 to 20, 20 to 30. 40 to 50. Yes. And Here is our frequency. Frequency is 2, 5, 6, 5, 2. Okay. So with this value, so we will calculate mode. So let's see the theory. So all of you know that mode is equal L plus, oops, yes, L plus F1 minus F0 divided by 2F1 minus F0 minus F2. This is our easiest formula, okay? So that's why I write like this. So let's give some definition. What is L, H, F1, F0, F2? So at first, F1 is nothing but F1 is the maximum frequency. Okay, maximum frequency. Then that means maximum frequency, this 6 is our F1. Okay. Just a second. Why it's, yes, now it's okay. Now F0 is frequency of the previous class of F1. What is the previous of F1? 5. That means this is our F0. What is our F2? Yes. F2 is the nothing but frequency of the next class of F1. That means it's 5. Now, okay. L, already we know that lower limit of the highest frequency class. Just a second. Let me zoom out it. What is the problem? Oops. Lower limit of highest frequency class. Yes. And what is our age? All of we know that. Class width. Yes. Now, let me write here the theory again. That is, oops, F1. F1 minus F0 divided by 2F1 twice F1 minus F0 F2 into A's, whole into A's. And now the value of L is here. This is the maximum frequency. So if this is the maximum frequency, that represent this class, and this is our L value. That means 20. After that, 6 minus 5. 6 minus 5. 2 into 6 minus 5 minus 5. And class width is, what is the class width? 10 unit. Oops. Yes, 10. So if we calculate, it will get it 5 and all total 25. That means 25 is our mode. That means something like this. Inside the 20 to 30 class, suppose 25 is the maximum number. That means it repeats 25, 25, 25, 25, 25 like this. And one is suppose 26 like this. So this is all about our mean, median, and mode. After that, we will go for standard deviation, standard variation. Okay. If suppose, just a second, why is not zooming out? No. Yes. We can start from here like this. Our standard deviation and variance. Yes, yes, Krishna Verma, don't worry. It's just simple mathematics. Just you have to remember the theory, okay? So we will see it for two scenario, okay? So I'm writing here, that means for two scenario. One is our population and one is sample. Population data and sample. So let's take an example. Don't tense about the PDFs, the notes. Just try to understand what we are actually learning. Okay. So suppose this is our 26, 32, 37 and 40. So this is our example. Okay. A group of number. And now all of you know that how we'll find out the mean sum of all data value divided by total number of values. So suppose 25, 26 plus 32, 37, oops, 40 divided by 5. 160 by 5 is equal 32. So is it okay? I need a comment a lot of time. I'm not asking for your comment. Whatever we discussed, 3 maths, is it okay? Or any doubt? Yes, okay. So just wait for some time. Just wait. Don't leave. I am seeing that only 64 member is viewing. After that, our most important part, why this is. So after that, we will see in our Jupyter notebook what is the use of those mathematics, simple mathematics. Okay. So just after until we done all these things, just standard deviation and variance. So now this is 32. That our sample mean is 32, and also all population mean is also all 32. Okay. And here one more thing, that sample mean is represent with capital X bar, and population mean represent with mu. Okay, this side is called mu. And all of we know that this is the sum, that means the addition symbol. Okay. So now here our X bar is equal 32, and also our mu is 32. I think, is it okay up to this? Now let's create a table for population variance. Yes. Wait. Yes, population variance. So at first our data value, that means it represent with x. Oh god, 25, 26, then 32, 37, 40. Yes. After that, the mean that represent x bar is 32, 32, 32. Yes. After that, for population variance, at first I will write the theory that what is population variance. So yes, population variance that represent with a small sigma square, and this small sigma square is equal summation of x minus mu whole square divided by n. Okay, so just here already we get x and x bar. So this is our sample mean. Now if we here need that population mean that represent with mu, that is also 32, 32, 32, 32, yes, like this. After that, we need x minus mu. So simply x minus mu. So let's calculate 25 minus 32 minus 7. Here I'm giving yes like this. Minus 7, minus 6, 0, 5, and 8. Yes. After that, we need the square. Okay. So x minus mu square, that is equal to 7 into 7, that is 49, 36, 0, 25, and 64. I think up to this is clear. Now summation x minus mu whole square, that is all the sum of this. That means if you sum all of this, so just a second. 49, 36, 25, 60. Yes, 174. So after that, just a second. If we give the value here 174, and what is our n value? 1, 2, 3, 4, 5. 5. So that is 34.8. So this is our population variance. Okay. So we got a result. Population variance is 34.8. Now what about sample variance? Yes. For our sample variance, S square is equal summation x minus x bar whole square divided by n minus 1. So the value of mu and x is same. That means the x minus mu square will value is same as x minus x bar whole square. Okay. So simply 174 5 minus 1 is equal 43.5. So this is our sample variance value. So I think up to this, all of you clear. There is no scope to not to understand it. I think it's clear. Now, what is the standard deviation? That means population standard deviation sigma is equal root over summation x minus mu whole square divided by n. That means what is the value? 34.8. So root over 38, oops, 34.8. Just a second. Yes, 34.8. That is equal 5.9. So that is our population standard deviation. After that, sample standard deviation, that is nothing but, yes, root over summation x minus x bar whole square divided by n minus 1. What is our value? That is 43.5. So 43.5, that means it will come, just a second. Yes, 6.6. So we will see the standard deviation. Now we will go for hypothesis testing. And from here, hypothesis testing we will do a math inside our Jupyter notebook. So at first, let's move inside our Jupyter notebook and simply we'll create here a new Python block. Just a second. Yes. So at first we'll write our problem. Then we will go for what is hypothesis testing, what is p-value. But at first, I want to show what kind of problem, why this hypothesis testing, what is this exactly. Okay, so I will use a simple that all of you can understand. So suppose I'm writing total all the, yes, what is our problem exactly? So a researcher claims that the average wind speed in a certain city is 9. So this is a claim. Claim means, yes, all of you can understand what is a claim. Okay. So what is this claim? That the wind speed in a certain city is 9. Okay. So, but I am also a researcher, but I will deny your proposal. That no, it's not possible. So give me some evidence. That's why I will agree with you. Something like this. So exactly inside this kind of claims, this hypothesis testing will give us the evidence that yes, you were right or not. Okay. So we will take a sample. Okay, what kind of sample? That means suppose a sample of 36 days wind speed. So we will capture the wind speed until 36 days, and after that we will store this group of sample, and we here we can see that the average speed is 9.2739 something. Okay, suppose like this. For testing that this claim is right or not. If it is right, we'll accept. If it is not right, we'll directly reject it. Okay. So let me write the full problem. After that, we will go for the definition. What is exactly p-value and hypothesis testing? 36 days has an average point speed of 9.273976, yes, miles per hour. But our claim is that average speed is 9. But after sampling, the average speed is 9.27. Okay. So let's see. So the standard deviation of population is 0.8 mile per hour. Okay. So here we exactly need the standard deviation formula. Okay. So why this mathematics? Why this standard deviation? Why this formulas? Okay. So already they are given in the question that the standard deviation of population is 0.8. Okay, after sampling the data. So we don't know 36 days data, we don't know, but they calculated that yes, the standard deviation of the population is 0.8 mile per hour. Okay. Yes. Now we'll set a alpha value. I'm coming. What is this alpha value? Alpha value is 0.01. Okay. And they give me a question for me that there is enough evidence to reject the claim. So question mark. And they also give me a that means you just use the p-value method. Yes. So this is clear. This is a claim. Now we have to prove this claim that we will reject it or not by the mathematical solution. Okay. So remember this alpha value. Okay. Now I'm coming here. What is those things? So here am writing, yes, hypothesis testing. That means when we perform a hypothesis test in statistics, a p-value help us determine the significance of the result. So what is this p-value? Okay. So I'm writing that you can remember it, that the p-value, or you can say probability value, is the probability of, okay, probability of getting a sample statistics such as mean or a more extreme sample statistics in the direction of the alternative hypothesis when the null hypothesis is true. That means I'm going again here in the problem. That means you are saying that, okay, the that means you are saying that the wind speed is 9. Okay, so the wind speed is 9. That means here our null hypothesis okay, mu is equal 9, and our alternative hypothesis mu is equal not 9. That means you are a researcher. You told me after your research that for a certain city the wind speed is 9 miles per hour. But as I am a researcher, I told you that I collect 36 samples and here I get the mean, that means 9.27 something. I am not agree with you. So I just create a claims that please give me the evidence that that's why I can agree with you. Okay. So here is the alpha value. Okay. So for this alpha value, so if I also give you the value alpha, so if the p-value, carefully see, if the p-value is less than equal alpha, then reject the null hypothesis. And if the p-value is greater than alpha, then don't reject the null hypothesis. So here we will take just 5-minute break. So till what time the class expected to go on? Just we will solve this problem with our Python, okay, with Python simple mathematics. After that, it will okay. Okay, just until 8:30, we will complete it. Yes, don't go anywhere. Just keep patience, because if you learn, so if you learn, just learn more and more. This is a free session, so here is a chance. So don't miss the chance, okay? And just 5-minute break. I'm coming after some drinking water. Just 5 minutes. So, okay, students, welcome back. So, what is the alpha value 0.01 means? Okay. So, an alpha level of 0.01 means that you are willing to accept up to 1% chances, okay, 1% chance to reject the null hypothesis. Okay, when the null hypothesis is actually true. Okay, actually true. So here, if our p value is, so we will see that our p value is less than equal alpha, or our p value is greater than equal alpha. So for this, we will maintain just 5 steps. Okay, just 5 steps. And one more thing, that if you graphically oops, just a second. Yes, like this. So this is our 9, and here is, suppose this is our alpha values. Okay, so it could be that mu is not equal 9. That means it could be greater than, or less than. Okay, so now we'll write here our 5 steps, and we will do. Let's start. So our step 1, that is, state the hypothesis and identify the claim. This is, and state the, yes, claim. So what we state, just a second. Yes, state that H0 is equal 9, and another is that means the null hypothesis is H1 colon mu. Okay, so like this, mu is equal 9, and another is alternative hypothesis, mu not equal 9. Okay, and so it's fixed. After that, step 2 is step 2 is test the value compute. Okay, now here we need the z value. Okay, standard. So how can we get the z value? So our z value is x bar minus mu divided by sigma by n. So now you can see where is the standard population is using. Okay, whatever we discuss here, yes, sigma. Okay, so we need the z value, so that is root over n. Oops, sorry, yes, root over n. So now what is our x bar? Here you can see for 39 sample, for the 36 sample, that is our value. Okay. Oops. Yes. So yes. So now we will calculate it by our Python mathematics. Okay. So let's start for sampling some data set. How could we create? So just follow me. Okay. This is so important. Okay. Yes. So we will import a random, okay, a random module. We will import pandas as PD because we need 36 data set. Okay. So, and we will a random list, that is an empty list. After that, we'll run a loop that for I in what is our range. So I am declaring here a range that is n is equal 36. Okay. So what is our range? Range is our n. Okay. And here inside this random list, it's an empty list. So I'm calling this empty list that, hey, random list, inside you append, by this append function, append some random values, random float values. Okay. So for random float value, we will use random.uniform. Okay. Random.uniform, and we will give the range that something like this 9.1 to 9.5. That means give me 36 value from 9.1 to 9.5. Okay, so we will see just a second. After that, okay, we will create a data frame. All of we know that how can we create data frame? Oops, yes. Inside this data frame, random list, inside this data frame list, I just already give a list. Okay, now already this list is converted into a data frame. Okay. After that, I want to view the data set. So if I df.hit, yes. Can you see here 9.27, 9.46, 9. And what is the shape? Yes, 36 into 1. Is it clear to all of you? how can I create a data set? Hello? Yes, clear. So I already create a data set like this, and I already save it with this function, that df dot to save to CSV. And after you give, if you is here give the path, it will save inside your folder as a CSV file. Okay, so you have to just give the .csv format. Okay, so I already create it, so I don't I just show you that how you will create a data set like this. Okay, random, by this random. So if you, that is for float purpose. Okay, 9.1 to 9.5. But if you want to create, if you want to create an integer data set, then you will use, just a second, oops, I forget it. Okay, okay, don't need it right now. Okay, so let's load our data set. Import pandas as pd. After that, I have a file, just a second. I have already a data set. Yes, for here is the hypothesis testing. This is the final data set. Yes, final wind record. So I will simply copy the link and I will paste it here. So my df is equal to pd read CSV, give the path, after that df dot hit. Oops, path is not available because, yes, so users, yes, now it's okay. Now here is a unnamed column and we will simply drop it. Okay, how can you drop it? From data, all of we know that drop data dot column. Yes, 0th column I want to drop. Axis is 1, in place is true. Oops, yes. Now data dot hit. Sorry, this is df. Yes. Now it's okay. Okay. After that, we will import math module, and after that we need the mean. Okay, so mean of this sample is equal, mean, suppose sample data is equal data dot mean. Okay, it will sorry, not data, this is df. Yes, df dot mean. After that, hypothesis mean is our 9. Where is 9? Yes, there is 9. Hypothesis mean. That means this claim. Okay, 9. After that, our n is 36. Yes. After that, standard population is 0.8. Here, standard deviation of population is 0.8. So standard population is equal 0.8. Okay. Now I want to print all of this. Standard deviation is, oops, yes. After that, hypothesis mean, hypothesis mean is hypothesis mean. After that, total number of sample. Yes, total number of sample is n. Yes. So we can see 9 point, yes, because yes, here the mean is. So we simply calculate it by this df dot mean. Okay, for this data set that already I saved. I exactly I created it for you. Okay, I created, and here is alpha value. Alpha value is 0.01. So step 2 is exactly, okay, step 2 is exactly the test the value compute. Okay, so test the value compute means we need to we have to find out this z value. Okay, so here is 30, just a second, what is our, yes, 9.273976 minus 9 divided by sigma. Oops, Our sigma is what? Sigma is 0.8 divided by root over of 36. So we need it. So just simple right here. Already we import math. After that, so our z value is equal. So mean of sample data divided by hypothesis mean, that is our x. No, not divided by, it's minus. After that, whole divided by standard population standard population divided by, here we will use the square format, root over square, whatever we learned yesterday in NumPy. So math dot SQRT, inside this, what is our n? Yes, n. So if we do that, after that we just simply print z value is, yes, we can see that 2.054. Okay, so now we have to observe z values. We have to find, here is for you, that here is our z value graph. See here, 2.05, this is 2 and this is 0.5. Okay, so that means 2.05, that means this value. This value is 0.97982. Okay, remember. So observe z value is 2.05 is equal 0.97. What is this? 97982. Okay, yes. So what is our exact p value? This is not our p value. Okay, so for p value we have to do this 1 minus 0.97827. Okay, suppose this is f is equal. After that, our p value will f multiply 2. Why this f multiply 2? Because both sides, we have to calculate it for both sides. If someone is say for this claim that, sir, this is the wind speed of a certain city is greater than 9, then only we will keep this greater, not this side. We don't need this side for greater. For smaller, we don't need this side. But there is, here we can see, there is mu is not equal 9. That means it could be greater or less. Okay, so that's why for both sides we have to multiply it into 2. Okay, So if we do that and print our P, that is 0.0446. So now our third step is over. That means just 5 minutes more. Already we done this. Okay, just 5 minutes. Step 3, find the p-value. Yes, already we find the p-value. After that, make the decision. Okay, now how we'll make the decision? Make the decision in this step. We can easily run a conditional statement that if my p-value is greater than alpha, okay, my p-value is greater than alpha, print do not reject the null hypothesis. And else print, that means if my p is not greater than 2 alpha, so print reject the null values. So let's see. Okay, alpha values. Okay, because we initialize here alpha value, this variable. Okay, here we go. So our decision is telling us that do not reject the null hypothesis. So what is the summarize of the result? So last, that means our final step, step 5, that is summarize the result. Okay, so what is the result? That we can say, it says that do not reject the null hypothesis. That means this claim is useless. Okay, so we can write here that there is not enough evidence to reject the claim. Is that the average wind speed is 9 miles per hour. So what is the overall summarize? That means this researcher is wrong. Okay, so that means there is not enough evidence to reject the claim, because here we can see p is greater than alpha. So we already said that if p value is less than alpha, reject the null hypothesis. But if p value is greater than alpha, do not reject. So that means we cannot reject this claim. So all of you, please assure me that you understand or not. What is the hypothesis testing? Yes, yes, yes. Yes, that means yes, yes, yes. Okay, okay. Okay, so we will stop here. Thank you for your patience, all of you. Okay, so tomorrow we will start with our matplot library, and we will going to see some bar plotting, scatter, and something like this, whatever. Yes, thank you so much. And any kind of issues, contact with our bot. Yes, yes. Okay, okay. Okay, CSV file. Just create a CSV file like this. I show you. How can you create? Yes. Look at here. Just use random module and create a data city with your own. Okay. And how can you save it? Just df dot to CSV. After that, give your file path where you want to save it. Okay. Okay, okay. I will send all the files. Okay. Today I will send it. Don't worry. Okay. So thank you all for your patience. 3 hours. Oh my God. Yes, 3 hour patience.